Hey everybody, hope your week's off to a good start. Mr. Fransky here. We're going to talk about some more trig-proof strategies today. We don't have very many so far. So far, really all we have is putting everything in terms of sine and cosine. That was our first strategy. Then we learned about common denominators. And especially for that, if we have like a 1, remember that can be anything. It could be cosine over cosine. It could be more complicated. It could be like 1 plus tangent over 1 plus tangent. Sorry, I'm not writing this very well here. Got to a plus tangent. And then the last one that we've used so far is just Pythagorean identities. And really, at this point, you can already do the first packet that you got, the green one. And with the Pythagorean identities, you can also probably do the blue sheet. But there's just a couple more things on there, and especially on the pink packet, the mixed trig proofs, that you're going to have a couple more strategies. So we'll take a look at some of those today. All right. So the first strategy we're going to talk about here is factoring. And the simplest form of factoring is just factoring out of GCF. So this is very similar to just factoring that we've seen before. If you have like x minus 2x, you can take an x out of that, and you're left with 1 minus 2, right, which is negative x. Right? You could have seen that up at the beginning, but just kind of showing you can do that. So here we have a cosine in common. So what do? We take it out. So you pull out a cosine x, and you're left with 1 minus sine squared x. Now, notice this one didn't have like a prove or a show. There was no equal sign. But let's see if we can do a little bit better. 1 minus sine squared, excuse me. Remember, when I box these, it means that I'm using what? That's a Pythagorean identity. 1 minus sine squared is cosine squared, because sine squared plus cosine squared is 1. So 1 minus sine squared is cosine squared. This is cosine x times cosine squared x, which is cosine cubed x. Okay. So we've simplified this down to cosine cubed x. We could have done that as a proof if they had given us the right side. Kind of cool. So this is kind of level 1. That's kind of the simplest factoring that you could see. A little bit different is factoring a difference of squares. So remember, if you have like 25 minus x squared, remember that's 5 plus x, 5 minus x. Oh, minus x. So this is kind of like that. For factoring this guy, we have 1 minus sine squared, so 1 is a square, it's just 1 squared, and sine squared is sine squared. So I can factor this as 1 plus sine x times 1 minus sine x. And you can check by foiling if you want to. 1 times 1 is 1, minus sine x plus sine x, and then minus sine squared x. Sines cancel, as 1 minus sine squared x. Okay, that checks out. But really, all we're looking for here is if you have 1 minus sine squared x, 1 plus sine x, 1 minus cosine x. So that's useful if you have like cosine squared divided by, let's say, like 1 plus sine x. This is probably an example down the line. But the top is 1 minus sine squared. That's by Pythagorean. Over 1 plus sine x. Now I can factor the top to 1 minus sine x, 1 plus sine x. And on the bottom I have 1 plus sine x, so it cancels out. Okay, so just kind of a cool little way to be able to see, oh, I can make some of that go away. You're just left with 1 minus sine x. Kind of cool. All right. The next one is factoring into linear factors using a trig function. So for this one, the weird thing is that it kind of looks like a quadratic, right? We got sine squared plus 2 sine minus 8. So if I just told you to factor, let's use y's since we have x's over here. If I told you to factor y squared plus 2y minus 8, you'd be like, oh, okay, that's y and y. And then to make 8, multiply to 8, add to 2, it's going to be a 4 and a 2. It looks like probably positive 4, negative 2 to go up 4 and then back down 2 to get to 2y. This is exactly the same thing. So the goal is to be able to get you from here to here kind of without having to think of intermediate steps. But if you're having trouble because these are signs, often what people do is what's called u substitution. So say let u equal sine x. Okay, so let u equal sine x. So then this would be rewritten as u squared plus 2u minus 8. And then we factor it, which is just like we did over here, u and u. And then we'll have to have a 4 and a 2 plus 4 minus 2. And now we put our signs back in. So it's going to be sine x plus 4 times sine x minus 2. And you can check here, if you multiply it, sine squared x minus 2 sine x plus 4 sine x, that's positive 2 sine x, and then minus 8 altogether. So that's kind of just factoring using linear factors. So why do we need these? Well, let's see if we can do some of these proofs. So we're trying to, once again, that word show is here. This is exactly the example I just did. But let's give it a shot. In fact, if you want to try it on your own, you can pause the video and try it on your own here. If you want to see if you can make the left side equal the right side, why don't you give it a shot? All right, let's do it together. So cosine squared, I want this sine x plus 1 to cancel out because this is not a fraction on the right, so that must go away. So I'm going to use Pythagorean identity here. This is 1 minus sine squared x divided by sine x plus 1. So now I can factor the top. That is 1 minus sine x times 1 plus sine x divided by sine x plus 1. Now, you don't need this extra step in here, but I'm going to do it. So I'm going to rewrite this 1 plus sine x as sine x plus 1. So 1 minus sine x. Sorry, I'm hanging out with some dogs here. If you can hear Ruggers. No. Thank you. He likes to whine. All right. Hey. All right. So we got 1 minus sine x times, I'm going to rewrite this, Ruggers. No. Times sine x plus 1. Divided by sine x plus 1. Those cancel out, and we have 1 minus sine x, which is what we wanted. Proof square. Cool. All right, let's take with another one. So here, a little bit more involved. We got sine squared over cosine squared minus 2 cosine plus 1, trying to show it's 1 plus cosine over 1 minus cosine. So let's start off. The bottom here looks like it could be factored, so maybe we do a little factoring on the side here. So we rewrite that with u's. We have u squared minus 2u plus 1. So that'd be u and u, 1 and 1, negative and negative, which is u minus 1 squared, which, if we put the cosine back in, that is cosine x minus 1 squared. So now we can write this as sine squared x. I'm just kind of start with the left side. So we have sine squared x divided by cosine x minus 1 squared. Well, it looks like I just want a 1 minus cosine on the bottom. So right now this is kind of backwards. We'll deal with that later. But the top, I think I can make something go away if I change that to 1 minus cosine squared x. So we write this as 1 minus cosine squared x divided by cosine x minus 1 times cosine x minus 1. I'm going to write it like that because we kind of want one of those to cancel. Looks like we want one to stick around. So I'm going to write the top as 1 minus cosine x. We're factoring as a difference of squares. Times 1 plus cosine x. So we had to factor the bottom as a product of linear factors. And the top we changed to 1 minus cosine squared, and we factored that out. So now on the bottom, we have cosine x minus 1 times cosine x minus 1. Now, these are not quite the same. But if you remember from before our negative management, so what we need to do here, negative management. So what we need to do here is we need to mix this around. So remember, if I multiply this by negative 1, negative cosine x minus 1 would be equal to 1 minus cosine x. And that would cancel out with the top. So what I'm going to do is I'm basically factoring out a negative here. So I'm going to rewrite this, and if you're lost here, just stick with me for a second. So we have 1 minus cosine x times 1 plus cosine x divided by negative 1 minus cosine x times cosine x minus 1. Okay? So now, these guys cancel. So all I did here is pull out the negative. To convince yourself, if you factor this in, you'll have positive cosine x. You'll have positive cosine x minus 1. And so now we can do is we can cancel these out. So now, let's see here. We're not quite to what we want. Let's see what we have right now. We have 1 plus cosine x divided by negative cosine x minus 1. Now that negative I'm going to bring in on the bottom now. So we have 1 plus cosine x divided by positive 1 minus cosine x, which is what we wanted. There we go. Cool. That's our proof. So one more strategy here, and it's kind of my when in doubt. This is kind of like if all other strategies have failed, what the heck can I do? And especially if you're in a fraction like this and you have a subtraction or an addition on the bottom, what you can do is you can multiply what's called the conjugate. Okay, so when in doubt, multiply by the conjugate. That's kind of my mantra. By the conjugate. And sometimes it works out, sometimes it doesn't, sometimes there's other strategies you can use. But let's see what happens if we start with the left side here. So starting with the right side, maybe it looks more complicated, but I'm going to show you what we can do if we start with the left. So this is kind of our last strategy here of the day. So we have 1 over 1 minus sine x. I'm going to multiply by the conjugate of the denominators. Remember, the conjugate, and people always say complex conjugate, but complex, remember, only involves i's. And if you remember that, it's like a plus bi, the conjugate is a minus bi. When you multiply them together, stuff goes away. The same thing kind of happens with trig, but we have no i's. So what I'm going to do is I'm just going to multiply this guy by 1 plus sine x over 1 plus sine x, and we'll see what happens. So upstairs I get 1 plus sine x. That right away kind of tells me that I'm on the right track. Then on the bottom, if you FOIL this, you get 1 plus sine x minus sine x. Those will cancel. Then we have minus sine squared x. And you guys should hopefully recognize that as a Pythagorean. So that is 1 plus sine x divided by cosine squared x. And we're done. That's all you have to do because we got our right side. So multiplying by the conjugate is kind of like a last resort. Often there are other things you can do to try to make it work out, but in this case, it ends up working. So it's important to be able to do. Okay, so really now you can work on the first 3 worksheets and packets that you guys have. So the green one we got last week in class. If you were absent, you'll have to get that. And then the blue one is new. It's just a single page, and it says Pythagorean identities, I think, on the top of it. And the pink one says, like, mixed proofs. And the pink one is actually a really good packet. And just kind of looking ahead, we have a quiz coming up. And that quiz covers kind of all of these proofs that are on these 3 packets. I'll be back, and I'll be able to take questions on Thursday. And then we will have the quiz on Friday. So remember, you can text me on Remind if you have any extra questions. I love you guys. That's why I'm here. Have a great day.